In this video, we're gonna try to find the equation of a given line under the action of a translation. We're gonna work in specifically on a given line and a given translation. This one can be applied in general to any translation and any line. But for us, we want to be specific. For that, we have this line, x minus y plus 2 equals 0. Okay, I have graphed the line here on the x-axis and the y-axis. And I want to see what happens to this line when we translate it by this vector that we're going to use 3 minus 4. So this vector 3, 1, 2, 3, minus 4. Okay, approximatively. So I'm going to move this line here by this vector. So I'm going to see what happens to its equation in this case. So that's my aim. And from there, I can find the equation easily. I can do this in many different ways. So first, I know how to write the analytic expression for the translation. So it's the new coordinates of any vector that I moved. It's going to be x prime, y prime is given by the old one, xy, plus 3 minus 4. So the x prime is going to x plus 3 and the y prime is going to y minus 4. So it's given any point, it's going to be moved 3 units on the x-axis and minus 4 units on the y-axis. For these points, let's call it A. It has coordinate minus 2, 0. So it's going to be moved 3 units on the x-axis and 4 units on the y. So it's going to be here. So its coordinates, they're going to be, we can check them from here or here. So they're going to be minus 1, minus 4. The same thing for this coordinate here. So this one is going to be moved 3 units here and 4 units down. So it's going to be something like this here. So it's going to be 3 minus 2. This is, let's call this one B, and this is B prime. Now we can draw the line. So this is my line. This is the action of this line. This is what happens to this line under this translation. So this is the line that I get. So I can say I can profit from this one. I have these 2 points, A prime 1 minus 4, and I have B prime 3 minus 2. I can construct the line, the equation of this line, and get the equation. But there is another way. Okay, so and now the equation of the line is given by x minus y plus 2 equals 0. So if we can solve from here, you can solve for x and plug to get the x prime, y prime, the coordinates or the points for this line. So we can solve here. So if I solve, I get x is x prime minus 3 and y is y prime plus 4. So I can plug here. So I know the x. So x is going to be x prime minus 3 minus y prime plus 4 plus 2 equals 0. So I have x prime minus 3 minus y prime minus 4 plus 2 equals 0. So I have x prime minus y prime minus 3 minus 4 minus 7 plus 2 minus 5. So the equation of my new line is this one. Since x prime and y prime can be any, I can call this one x minus y minus 5 equals 0. So this is the equation of my new line. Okay, so if I check here, when x is 0, y is minus 5. So this is the point. So this is my point. So when y is 0, x is 5, you can see it here. This is not done to scale, but you can see I almost get them, right? Exactly. So the equation for this line is x minus y minus 5 equals 0. Okay? This one, the technique that I used is for a particular vector and a particular line. In fact, if you use any vector, like say AB, and you have your equation of the line as some alpha x plus beta y plus some c, you can use this vector here, this translation, to find the general formula for the given line. So this one is good in animation or technique. Sometimes you have someone moving here and someone is moving here parallel to this line. Okay? We want to find the animation for this one moving here, but we need to know the equation of this line. This is how we get the line. Because by the end, we want to parameterize this line and have its x and y coordinates depending on time and see the moving object, the behavior of the moving object. Okay, anyways, as I said, the technique works for any line. Thank you.